In this video, I'm going to be answering two main questions. The first one is, why is the sky blue? And the second one is, why are sunsets orangish red? Now, the sun is radiating all different colors of light. As you've probably seen before with this color spectrum, Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet are all the different colors of the rainbow that are coming from the sun, which all have different wavelengths. The red, being the weakest energy level, has a wavelength about 700 nanometers, and then violet, which is the highest energy that the sun is releasing, visible light, is about 400 nanometers. Now, what happens is, as this light comes down from the sun, it interacts with the air molecules. Now, the air molecules have a resonant frequency that is around this region over here that's blue and purple, which means that as it absorbs the energy from the sunlight, the electrons vibrate and it releases blue and purple light, which is known as Rayleigh scattering. So in the upper atmosphere, that's where a lot of the scattering occurs that we see. And those nitrogen and oxygen molecules, which air is predominantly composed of nitrogen, which is about 80% of the air, and about 20% is oxygen. And as the sunlight interacts with those molecules, it scatters blue and violet into the air. Now, you might be wondering, why doesn't the sky appear more purple then? Well, although the air molecules scatter a lot of that blue and violet light, our eyes are not very sensitive to picking up that violet light. That violet light is the one that's hardest for our eyes to detect on this end of the spectrum. So the blue is going to be much more predominant, and for that reason, the sky appears to be blue. So with that scattering, it's basically the air molecules that are pulling the blue and violet out from the sunlight and then spreading it all around the sky. And then our eyes mostly collect that blue light. Now, when we take a look at the sun, we are mostly seeing this yellow disk. Now, because it's shooting out all different colors of the rainbow, that's supposed to be appearing white. But the air is pulling out a lot of this blue and purple, which mostly leaves red, orange, yellow, and green. Now, right in the middle there is a yellowy orange color. And if you mix red and green together, red and green light actually make yellow light. So that's why the sun appears to be yellow when we're looking directly at it, but then everywhere around it is going to appear more blue because of that Rayleigh scattering and the air pulling out that blue and violet light. Now let's talk about how sunsets are reddish orange. Now what happens is, we'll say maybe around noon, at 12 o'clock, right in the middle of the day, the sun has the shortest path to reach you. And we'll just say that you are located right about here. And then as the Earth is rotating, the position of the sun relative to where you're at is going to change. So say, for example, the sun is now over here, and we'll say maybe it's about 5 p.m. Now at 5 p.m., what happens is you get a lot more of that red, orange, and some of that yellow light. And that's why the sunsets appear to be that reddish orange color. Now, what happened to a lot of that blue and violet before? Now, if you take a look at this distance from the sun over here at its 5 p.m. location to you, that distance has increased. So because that distance has increased, there is more scattering. And remember that scattering is the air molecules that are pulling out the blue and the violet. So now if it has a greater distance to be scattered, it's going to pull out more of that blue and violet. That blue is going to become much more pale, and more of these warm colors are going to come through, therefore causing a pale blue sky with those warm colors such as red and orange. So I hope that was helpful in helping you answer the two questions: why is the sky blue and why are sunsets reddish orange? Thank you very much for watching and listening.